renewable energy is generated, the big question becomes, what next? You see, energy generated without proper management is not a step forward. This is why we have designed the Blieu Box, our energy consumption management system for improved renewable energy distribution and use in underserved areas.
So here is our renewable energy solution. We have three different subunits here. We have the power generation tower. We have an intelligent circuitry to help us optimize how much energy we capture from the solar panels by intelligently actuating the units to face the direct intensity of sunlight. The highest intensity of sunlight will capture the highest optimal charge for our DC cells. Here we also have DC cells like I just mentioned, and then we equally have our power management to distribution system, which we intend to deploy for underserved areas using renewable energy as a source of power supply. So we designed the power generation system to have optimal capture for sun intensity. By that I mean that we deployed some sensors which can be industrialized to actuate this system based on the highest intensity of sunlight. We use these sensors and the phone light to mimic the movement of sun over a dual axis position, which can be east or west and north and south. Right here we have an intelligent circuitry to achieve intelligent repositioning of the panel tray, which equivalently means repositioning the panel. Then we feed that signal over to the DC cell, like you can see here. The DC cell would help us store charge, of course, from the solar panels, which is supposed to be a DC power storage unit. And then we can move over to our product, which is called the Blieu Box, which is going to be a system that we intend to deploy for underserved areas. Now, this is our power management and distribution system. With this system, we can properly and efficiently manage the power generated from the solar panels. This would help us distribute power to different homes on an optimal basis. Like you can see here, we have added sockets. There are two sockets, socket 1 and 2, representing different homes. We're using this to simulate different home scenarios for an underserved area, whereby a single generation plant, is being made to serve different homes over a small village as a means of providing power, efficient power supply through using renewable energy means. Then we have deployed an intelligent IoT platform to work corresponding with the hardware, like you can find here. We have different homes registered on this platform, so we can appropriate power consumption to different homes. This means that no user can use beyond a certain range of power allocation by using of this system. The system is designed to run on 3 different processors, 3 different 32-unit processors, and it's also designed to sense current from any load point and then stream that intelligence over to the web platform. Like you can see here, we have sockets and monitors. We have display monitors for each of the sockets and each of the loading points. So users in different underserved areas can be able to optimally use energy from renewable energy sources without exceeding a certain limit. The system is required to connect to the internet for streaming user data. User data is referred to as any load used or consumed in any apartment. It shows not active as long as no loading point is activated in the building for as many buildings as are registered on the platform. On the web platform, we have all homes in the settlement registered as different nodes. For emphasis sake here in this video, we have used sockets to represent different apartments in these underserved areas. the status of each home reflects on the web platform. So the administrator can tell what load is being consumed per time in any of the houses within that settlement. This means that power can be efficiently distributed and managed properly using the industrial Internet of Things as a premise to stream user load data from any part of the community to some central points for processing. Right now we can see that the system is indicating that the user apartment is active with loading. This happens over the internet for both socket 1 and socket 2. That means we can decide to shut off the load if the user load is beyond the allocated amount of amp range per house. We can actively isolate the home from the renewable energy power grid so as to efficiently manage the power that is being generated.